If you track ByteDance's, this release matters because it targets the part that usually breaks in practice, the handoff from model output to real work. A lot of agent products can outline steps, draft code, or suggest commands. Then a person still has to copy the output, open a terminal, install packages, and see what fails. DeerFlow 2.0 is positioned as a harness that closes more of that gap. According to the source, ByteDance open source Deer framework, built to research, code, build sites, make slide decks, and generate video content by actually executing tasks, not just describing them. That does not prove perfect autonomy, but it does mark a product shift worth watching. The story here is simple. Agents are moving from assistant surfaces toward controlled execution environments. If that trend holds, the product question changes from how well a model answers to how safely, unreliably a system can act. The clearest claim in the source is DeerFlow's sandbox model. Instead of living only inside a chat box, the agent runs inside an isolated Docker container. That gives it a file system, a bash terminal, and the ability to read and write actual files. In plain terms, the system can move from proposing a script to running that script in its own environment. The source frames this as the main differentiator, and that feels fair. It addresses a common weakness in agent demos, where execution is implied but not real. The article also says DeerFlow has stateful memory and a persistent file system, which means it can retain project context, preferences, and writing style across sessions. That combination matters. Execution without memory is brittle. Memory without execution is just a better chatbot. Put together, ByteDance is describing a system meant to operate more like a continuing workstation than a one-off prompt response. The second big idea is orchestration. DeerFlow uses what the source calls a superagent harness. Basically a LED agent that acts like a coordinator. When a large task comes in, the LED agent breaks it into smaller jobs, assigns those jobs to superagents running in parallels and boxes, then gathers the outputs into a final result. The source gives examples like web scraping for finding data, competitor analysis, image generation, and then compiling everything into a presentation or app. That design is not new in theory. We have seen multi-agent decomposition in plenty of research and product demos. What matters is the packaging. ByteDance is combining decomposition, parallel execution, persistence, and file-level action in one open-source framework. That is more interesting than another claim that agents can collaborate. It suggests the product is less about one smart model and more about workflow architecture. In other words, the real feature may be coordination, not intelligence alone. One useful detail in the source is that DeerFlow apparently started as a deep research tool and was rewritten into a broader execution harness after internal users pushed it further. That product art matters, because it explains why the feature list feels so wide. The article says people use the Docker-based setup to build data pipelines, real-time dashboards, and full web apps, and that ByteDance responded by rebuilding DeerFlow 2.0 as a task-agnostic framework. If true, that is a familiar pattern in AI tooling. A narrow internal utility becomes a platform once users find the more valuable layer underneath. The source also says DeerFlow is model agnostic through OpenAI-compatible APIs, with support for swapping between major hosted models and local options through tools like Alana. that lowers lock-in and makes the framework easier to slot into existing stacks. For engineers, that may be as important as the agent design itself. The signal is clear. DeerFlow 2.0, as described here, is an open-source framework focused on execution-first agents, isolated sandboxes, multi-agent orchestration, persistent memory, and model flexibility. That is a concrete product direction, and it lines up with where serious agent tooling is heading. The noise is in the broader language around fully autonomous work. The source makes ambitious claims about building sites, presentations, videos, and complex pipelines. But it does not provide benchmark results, failure rates, security trade-offs, or detailed examples of how often human intervention is still needed. So the right read is not that ByteDance solved autonomous agents. It is that they packaged several important ingredients into one open-source harness and made that stack easier to inspect and use. That is meaningful. It reduces friction for teams experimenting with real agent workflows. But the gap between a capable harness and dependable production autonomy is still where most of the hard work lies.